All right, section 2.5 is on modeling real-world data using scatter plots. So whenever you hear math modeling, that means story problems. So these are kind of like story problems, real-life problems. So scatter plot. Have you guys seen scatter plots before?
Yes. Yeah.
Some say no, some say yes. Scatter plots just have like random points. So they may make a line, they may not make a line, and then usually there's what we call a line of best fit that goes through them. So a scatter plot is a bunch of points, so a set of data points graphed as an ordered pair, or as ordered pairs in a coordinate plane. And the line of fit is the line that closely approximates the set of data. So the best line can be found with a calculator. We're not really going to do the calculator method, but we're going to do something similar to what it does in class today. And the prediction equation is the equation of that specific line of fit. So 1A, it says the table below shows the approximate percent of students who sent applications to 2 colleges in various years since 1985. Make a scatter plot of the data. So the big thing about making scatter plots is you need to label your axes and you need to find a good I don't know, separation here. So go by certain points. So in our case we have 0, 3, 6, 9, 12, and 15. So we don't want to go by 1s. You could probably go by 3s. Maybe even every 2 spaces is 3. You can do that. That's what you did. So 3, 6, 9. Oh, you led me astray. So you're saying go by 2 is like 2, 4, 6, 8, like that? Okay. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, and that represents the years since 1985. Okay, now percent, it starts at 20 and then it goes down to 13. So can we go by, what did you go by?
You can go by 2s.
2 still? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that works. And that's your percent. So when we say percent, that's the percent of students who sent applications to colleges. And then we graph our points. So I have 0, 20. I have 3, 18. 6, 15. 9, 15. 12, 14. And 15, 13. Just like that. All right, and then we have to come up with this line of fit. So what your calculator does is it basically comes up with all the different lines that go through every pair of points, and it comes up with the line that goes through the most points or is the closest to all of the points. So the calculator basically does this method for you. What we're going to do is we're just going to find the equation of a line of fit, so a line that goes through. So if you took a ruler and you set your ruler against all those lines, so you guys can pass out these rulers if you want. I have a whole bunch of them. Send them that way. The different places, it looks like maybe you could go, oh man, it's yellow, kind of through there. That would be like a line of fit. Yep. I usually recommend, like Naomi's saying, the first and last dots, unless one of those is just way off where you think the line would be. So we're going to have it go through the first and the last. And that fits quite a few of them. So B says use a straight edge to draw a line of fit for the data. How well does it fit the data? So we're going to say it's pretty close. There's just a couple of points below the line, right? make a prediction equation. So how would we come up with the equation for that green line that I just drew?
Well, you have the y-intercept, so we just have to find the slope.
We actually have the y-intercept. That's 0, 20, so that's the y-intercept. And this other point was 15, 13. So we're just finding the equation of the line for those 2 points. So we have 0, 20 and 15, 13. So that means my slope is y2 minus y1, so 13 minus 20, over x2 minus x1, so 15 minus 0. So I get negative 7 over 15. Now Monica noticed that not only is that 2 points, but one of those points is the y-intercept. So you can just use y equals mx plus b in that case. You don't have to do the y minus y1 equals m times x minus x1. So it's just y equals mx plus b. So it's negative 7 over 15x plus 20 was the y-intercept. And that's your answer. Okay, it says, what does the slope represent? So in this real life problem, what do you guys think the slope represents? Maddie, what do you think? Jason, you want to help her out? You're stuck too? How do you interpret it? Monica, what do you think?
Like the amount of percent it goes down per year.
Yeah, so it's the amount that the percent of applicants is decreasing. So it's the rate that the percent is changing or decreasing. So that's your slope. And then your y-intercept, what's the y-intercept? Brian? What do you think the y-intercept is? Yeah?
Oh, well, I would say that the y-intercept is like the max percentage.
Not necessarily. Because we don't know what happened in the previous years, right? Naveen, what do you think? No idea. Alex? Do you know?
I have no idea.
Monica, do you know? Monica's the only one who
The
gets
amount of like percentage of applicants in 1985.
Yeah, it was your original number that applied in 1985, right? So it was the original percent that applied
I was close.
in 1985. All right, so you kind of need to think about what those values mean when you solve for them. All right, let's go to the next one. Oh, D, predict the percent in 2010. So in 2010, so 2010 is how many years after 1985? 25, right? So in our equation, x was represented by the years since 1985. So in our case, x is 25. So we're going to plug that into our prediction equation. So we have y equals negative 7 over 15 times 25, and then plus 20. So negative 7 over 15 times 25 added to 20, so I did it all on my calculator. I got negative 8.3 repeating. How do you do what?
Just divide.
How did I put it? So you can do negative 7 divided by 15 in parentheses times 25 and find that answer and then add 20 or just add 20 like that. It will work out. All right, so that means that it's going to be, ooh, was it negative? Not a negative.
Positive.
I was like, that doesn't make any sense. Yeah, 8.3. Yeah, so it's approximately 8% applied in 2010. So I guess people are not interested in those two colleges anymore. People don't apply to them. All right, 2A. So it says the table shows the number of calories burned per hour by a 140-pound woman or person running at various speeds, like the people down the hallway.
They're running exactly.
I don't know what they're doing. Make a scatter plot and draw a line of fit. So go ahead and do your scatter plot. So I'd say like every 3 or 4, make your, so 5, 6, 7, 8, just so they're not like super close to each other. Remember, you can label, so speed. And calories. And then this one starts at 508. So we don't want to do 50, 100, 200, or 150, 200. We don't want to have to do that. So we're going to, I always do this thing where I like do a little jagged. See what I did there? That means I've cut off part of it. And now I'm going to start with numbers. So I'm going to say, okay, I cut off a lot, and now I'm going to start at 500. 550, 600. So let's go by 50. So 50, 600. So every 4 is going to be 100. 650, 700, 750, 800, 850. Oh, that works pretty well. And then we're going to draw the scatter plot. So I'm going to have 5, 508. Then I'm going to have 6, 638. 7, 731. And 8, 858. Mine's looking almost like a line. Yours look pretty close. Yeah, so take your straight edge. And draw your line in. Now what's important to mention is when you guys do this on your homework, like right now it looks like it's going through 0, 0. It looks like my y-intercept is close to 0. But remember, I have that part that I cut off. So don't just assume it's 0 there, because I started kind of funny, you know. Okay, so be careful if you're doing your homework and it doesn't make any sense. Make sure that you didn't cut off part of your graph. You know. Okay, so make a prediction equation. So like I said, you usually want to use like the first and last if that one works out pretty well. So that way, if you guys are doing your homework, you guys can kind of compare if you always use the same points. Unless like the first point was way up here and it was way off, then don't use that point. Use other two. Okay, so we're going to use the point 5, 508 and the point 8, 858. So I'm going to find my slope. So 858 minus 508 divided by 8 minus 5. So 350 over 3. We don't know the y-intercept this time, so we're going to have to do the y minus y1 equals m times x minus x1. And we can use either point. So I'm going to use the 5, 508. So I'm going to have y minus 508 equals m, so 350 over 3, x minus 5. Then I'm going to simplify, so I'm going to solve for y. So I'm going to multiply the 350 in, or 350 over 3. You can do fractions on your calculator. Did you guys know this? So if I was doing 350 over 3, I would put it in like that. And I'd say, okay, I'm going to multiply by 5 or negative 5. Doesn't matter. And then you hit math, which is a button on the left, and then do 1 and enter. And then we'll change it to a fraction. So I get negative 1750 over 3. And then I'm going to take that answer, so you can do second answer, the negative button. So second and then the negative button. It pulls up that answer, and I'm going to add 508 to it. So when you do that, you get negative 75.3 repeating, but I want to see what the fraction is, so negative 226 over 3. Okay, that's our prediction equation. So C, if a 140-pound woman runs 5.5 miles per hour, so that's her speed, so that's the X value. About how many calories will she burn in an hour? Yes,
Did you say 236 divided by
226. It's kind of hard to read yet. Okay, so we're going to plug in X equals 5.5. So I'm going to have 350 over 3 times 5.5 minus 226 over 3. So notice these are all exact answers. Some of you guys on your homework, you would have like 4.3, or not 4.3, 4 over 3, and you would write 1.3. But 4 over 3 isn't the same as 1.3. It's 1.3 repeating. So when you do that in Algebra 2, you're going to get a lot of answers wrong because you're going to round so soon and you're going to use that rounded answer. So I would leave it as in the fraction form if possible. Okay, so I'm going to have 350 over 3. I'm going to multiply by 5.5, and then I'm going to subtract out 226 over 3. So I got y equals 566.3 repeating. As a fraction, that's,
1,699.
yeah, but since this is a real life problem, I would probably say approximately 566 calories, right? You don't say 566.3 repeating calories. That wouldn't make much sense. So about 566 calories.